Welcome again to today's lesson. This is the Solution Space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want us to continue with the vectors that I started with you in the previous videos. In the previous videos, we started learning about vectors, and we've already treated many subtopics on the vectors already in the previous videos. And the last thing that we looked at on the vectors is finding the magnitude or length of a vector, which we've done a detailed explanation on it, and also we've solved some examples on it as well in the previous videos. And I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to handle another aspect of the vectors, and that is we looking at some vector laws that governs a parallelogram. As you can see from the board, I've written parallelogram on the board, and this is the diagram for a parallelogram. So we are going to look at some vector laws that governs a parallelogram, and we are going to use that knowledge to solve some questions. And before we proceed, I would like to encourage you to do well to watch the previous videos that I've done on the vectors, because we are going to apply the knowledge that we've gotten on the vectors in the previous videos. We are going to apply it here. So if you don't have any knowledge on the things that we've done on the vectors in the previous videos, then you might struggle with this session, okay? Because we are going to apply the knowledge that we've gotten on the vectors in the previous videos. We are going to apply it here. So please do all to watch the previous videos that we've done on the vectors so that you can get a good foundation and understanding to be able to handle this session as well. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. So now, let's come to what I want to teach you in this video. I said that we want to look at some vector laws that governs a parallelogram. And a parallelogram is just a plane figure with two opposite sides to be equal. So this is the diagram of a parallelogram, and as I said that it's a plane figure with two opposite sides to be equal, meaning that the length here is equal to the length here, and also the length here is equal to the length here. So two opposite sides of the parallelogram are equal. I hope you understand up to this point. So now, before we can look at the vector laws that governs a parallelogram, we need to label the vertices of the parallelogram, which is very important. Okay, so I'm going to start by labeling the vertices of the parallelogram that I have on the board. Okay, so I'm going to start from here, label here as A, then I'll come here as B, and here as C, and here as D. Okay, and I've taught you how to label plane figures in the previous videos. Okay, I explained to you that when you are labeling a plane figure, you need to follow a particular pattern. Okay, you don't label it anyhow you want. Okay, so you follow a particular pattern, which is either you move in the clockwise direction or the anti-clockwise direction, which is very important. Okay, because if you mix the labeling together anyhow, then it's going to affect your solution. Okay, so now look on the board. I started from here, okay, as A. You can see that I moved here as B, here as C and here as D. You can see that I moved in the clockwise direction. Okay, someone can also choose to move in the anti-clockwise direction, and it's the same thing. So meaning that if the person starts from here as A, the person will come here as B, here as C, and here as D. Okay, so wherever you start from, you need to follow a particular pattern. Either you moved in the clockwise direction or the anti-clockwise direction. Okay, please take note that if you mix the labeling together anyhow, it will affect your solution. Okay, so always follow a particular pattern, and I say that you can choose to start from any point that you want. So what you need to make sure is done is to follow a particular pattern. Either you move in the clockwise direction or anti-clockwise direction. So someone can choose to start from here and either move in the clockwise direction or anti-clockwise direction. You will still get the same answer. Okay, I hope the explanation is clear enough up to this point. Okay, so now that we are done labeling the vertices of the triangle, then we also need to bring our arrows, okay, which shows the direction of the vector on the parallelogram. Okay, I've explained to you that we want to look at some vector laws that governs a parallelogram. And when we started the vectors in the first video, I defined a vector to you as any quantity which has both magnitude and direction. So it means without the direction, it's not a vector. Okay, that's why it's important that we indicate the direction on the parallelogram, okay, so that we can identify it as a vector. I hope you understand up to this point. Okay, so now we are going to indicate our arrows on the parallelogram, and since this is just an illustration, you will choose which direction that you want to move to. Okay, when we start solving question, you see that looking at the nature of the question, you are supposed to move in a particular direction. Okay, that's the question will determine that for you, but in this case we are using this as an illustration to derive the vector laws that governs a parallelogram. So we are going to choose our own direction. Okay, and what you need to take note is that the opposite sides of a parallelogram, they need to move in the same direction. Okay, so when you are indicating your arrows or your direction on the parallelogram, you need to make sure that the opposite sides of a parallelogram, they are always moving in the same direction. Okay, so now I will start with this side and I'll say that I'm going to move from A to D. Okay, so my arrow will point towards D, and that is me having the vector AD. Okay, so I'll move in this direction, A to D. Okay, so I have the vector AD moving from point A to point D. So my arrow is pointing towards D. Now, someone can also choose to move from point D to A. It's the same thing. But what you need to take note is that I've established that the opposite sides of a parallelogram, they need to move in the same direction, meaning that me choosing to move from here, from A to D, it means when I come to the opposite side of it, I'm supposed to also move from B to C, which is very important. Okay, so I'm supposed to move from B to C, so I have the vector BC. And take note that you cannot move from A to D here, and when you come here, you come and move from C to B, meaning that your arrow will point towards B. No, it is wrong. The opposite sides of a parallelogram always need to move in the same direction. Okay, very important. So if you chose to start from D to A, meaning that your arrow will point towards A, then it means that when you come to the opposite side, which is this side, you need to move from C to B. Okay, always the arrows need to move in the same direction. Okay, very important. So now let me come to this side also. I need to indicate my arrow. I will choose to move from A to B, so my arrow will point towards B. Then of course, when I come to the opposite side here, it means I'll move from D to C. Okay, so my arrow will move from D to C. Again, you cannot make here A to B, okay, meaning that your arrow is pointing towards B. Then when you come here, you do it C to D, meaning that your arrow is pointing towards D. No, the opposite sides of the parallelogram always needs to move in the same direction. So if you chose to make here BA, meaning that you are moving from B to A, so which means your arrow will point towards A, then it means when you come here, you need to move from C to D, okay, so that the arrow can move in the same direction. I hope the explanation is clear enough up to this point. Okay, so now keep in mind that we've established that two opposite sides of the parallelogram are equal. Okay, so we are going to use that knowledge to establish the vector law that governs a parallelogram. Okay, so now when I come to the board, this is our parallelogram. We've indicated the arrows on it, and you can agree with me that this side AD, okay, which is the vector AD, is equal to this side BC, which is the vector BC. I hope you can agree with me on that, because we've said that the opposite sides of a parallelogram are equal. So meaning that when I take my AD, which is this side of the parallelogram, it should be equal to this side of the parallelogram, which is BC. Okay, so I have my vector AD equals to vector BC. I hope the explanation is clear enough up to this point. And also, I can, so let me write also, we can have that my AB, okay, which is this side of the parallelogram, the vector AB is equal to the vector DC, this side of the parallelogram. So we can also have that my AB, vector AB is equal to the vector DC. I hope you understand and you agree with me up to this point. Okay, so from here, we are going to apply the position vectors that we've learned in the previous videos. Okay, I've taught you position vectors. We've done a detailed explanation on it. Okay, so we are going to apply that knowledge here. Okay, how do I get my vector AD? I've explained to you that it's always the position vector of the last letter minus the position vector of the first letter. Okay, and this we've treated into details in the previous videos, so we are just applying that knowledge here. So if I'm to write down the expansion of vector AD, is going to be the position vector of the last letter, which is the D, minus the position vector of the first letter, which is the A. So it's going to be OD minus OA. I hope you understand and you agree with me up to this point. Okay, so for the sake of those who don't know anything about position vectors, let me just do a quick recap on that. Okay, a position vector simply refers to a vector which starts from the origin. Okay, so having the vector AD, if I want to find the vector AD, it's always the position vector of the last letter minus the position vector of the first letter. So the position vector of the last letter, the D, is going to be OD. So OD, a vector which starts from the origin. That's why we have the O here. to indicate that it starts from the origin. Then you bring your D. So OD minus the position vector of the first letter. So it's going to be OA. Okay, so that's why I'm having this. So we are going to bring our equal sign and we are going to do same for the vector BC as well. Okay, so let me bring my equal sign, and to find the vector BC is going to be the position vector of the last letter, which is going to be OC, minus the position vector of the first letter, which is going to be OB. I hope you understand up to this point. Okay, so this is the vector law that governs a parallelogram. I hope you understand up to this point. So with that same understanding, we are going to do for this as well. Let's write down the expansion for the vector AD. So it's going to be the position vector of the last letter minus the position vector of the first letter. So the position vector of the last letter is going to be OB minus the position vector of the first letter is going to be OA. Then you bring your equal sign. Then we do same for the vector DC as well. So it's going to be the position vector of the last letter, which is going to be OC minus the position vector of the first letter, which is going to be OD. Okay, so this is the vector law that governs a parallelogram. Okay, so we are going to use this knowledge to solve questions in the next video. I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we apply this knowledge to solve questions. Bye bye.